Hi Algebra! In this lesson you are going to learn how to add and subtract radicals. And so it's very much like adding and subtracting like terms where they have to have the exact same variable with the exact same exponents for you to add them. So 3x plus 5x you can add together, and you add the 3 and the 5 and you get 8x. And remember, you do not change the variable. They have to be the same for you to add them, and then you don't change them. So if you had 3x plus 5y, we could not add those because they are not the same. If we had 3x plus 5x squared, we couldn't add them because they don't have the same exponent. So it's the same thing with radicals. 3 square root 6 plus 5 square root 6. Those are the same. This has to be identical for you to add them. And then just like here, where we only add the coefficients, we will only add the coefficients. 3 plus 5 gives us 8 square root 6. And that doesn't change, just like how that x doesn't change. This next one is the square root of 7. It has a coefficient of 1 plus 2 square root 7. So are these the same? Yes, they are. So you can add 1 plus 2 gives us 3 square root 7. So you add the coefficients, and then you don't change the radical. That stays the same. Okay, so this next one, 5 root 10 minus 7 root 10. Yes, these are the same, so it's 5 minus 7. 5 is smaller than 7. You're taking away more than what you have, so you're going to have a negative 2 root 10. Square root of 5 plus the square root of 5, those have coefficients of 1, so that's 2 square root 5. And now on this one here, the square root of 3 plus the square root of 7, those are not the same, and so we cannot add them. Now, the thing is that just because they aren't the same doesn't mean that they're fully simplified. 3 and 7 are fully simplified. How do I know that? No perfect squares go into them. Okay, so because no perfect squares go into them, they are fully simplified. So I cannot add them together because they are not like radicals. So that's just your final answer is just this, because you cannot combine them. Now, we went through that because sometimes you can simplify. But we'll get to those in a second. So here are some practice problems that I want you to do. So you're going to pause the video right now and you're going to do these problems. Okay, so you've paused the video. These are your answers. 6 root 2, 7 root 7, and those you can't add, and negative 3 root 3. So this would be your answer. Okay, now on these problems, we can actually simplify, because when we look at this, the square root of 2 and the square root of 8, those aren't the same. But is 8 simplified all the way? Like 2 is simplified all the way, right? That's as small as that radical is going to get. But is 8 simplified all the way? Are there any perfect squares that go into 8? Yeah, so we've had our list, right? You hopefully have your list. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, all of those numbers. So do any of them go into this? Yeah, 4 goes into that. So it's 3 root 2 plus the square root of 4 times the square root of 2. So it's 3 root 2 plus 2 root 2, because 4 square root of 4 becomes 2. Now they are the same, and I can add 3 plus 2, and I get 5 root 2. So now's where it's like, we've done the simple part, where if they're the same, you can add the coefficients. If they're not, you can't. But then you've got to check to see if you can reduce them. So we're combining what we did last time with adding now. So we've got the square root of 18 and the square root of 27. What perfect squares go into them? 4 does not. 9. 9 goes into this. So this is 9 times 2. And this is 9 times the square root of 3. So the square root of 9 is 3. Remember, if there's a perfect square, your answer does not have a square root around it. Right? The square root of, if it's in this list, any of the numbers in this list, the square root of this is 2. The square root of this is 3. The square root of this is 4. The square root of this is 5. The square root of this is 6. Right? Like, those don't have square roots around them. So I've got 3 root 2 minus 3 root 3. Now those are not the same, so we can't add them, so this would be our final answer. 2 root 12 and 3 root 75. So you're going to have your list, and you're going to be thinking what perfect squares go into them. 4, 3 times 25, and 3. So I put my perfect squares first. 4 goes into 12, 25 goes into 75. So it's 2 times the square root of 3 plus 3 times 5 times the square root of 3. So that's 4 root 3 plus 3 times 5, 15 root 3. So those are the same radicals, so it's 19 root 3. The next one, what perfect squares? Let's see, I know 9 goes into this, so 2 root 9 root 5 minus 2 root 4 root 5. So that's 2 times 3 root 5 minus 2 times 2 root 5. So all I did here was I simplified the perfect squares. And then I did 6 root 5 minus 4 root 5. And I can subtract those, so it's 2 root 5, 6 minus 4. So I hope you're getting the pattern. Is each step is you take out perfect squares, and then you simplify those, and then simplify the perfect squares, and then you multiply those coefficients, and then you add. So each time that's what you're doing. You're going to take out the perfect squares, then you're going to simplify the perfect squares, and then you're going to multiply those coefficients together and then add them to get your final answer. Okay, so simplify. That second one has a variable in it. Oh boy. I don't see a variable. The second problem down here. Okay, so this one, 5 times the square root of 15. Well, we've seen that you can multiply. So you can make it 5 times 15 plus 4 root 3. So 5 times 15 is 75. So 5 times 15 is 75. So that's 75 plus 4 root 3. Now 75 is 25 times 3. So I've taken out the perfect squares, so that gives us 5 root 3. Oops, 3, not 5. Plus 4 root 3, which are the same, so I can get 9 root 3. So only adding coefficients, not changing the radical. Same thing here. Don't worry about the variables. Remember, when are the variables perfect squares? When they have an even exponent. This one doesn't. It's an exponent of 1, which is odd. So I've got the square root of 4 times the square root of 3. I'm going to leave the k with that, plus the square root of 9 times the square root of 3k. I'm leaving the k with the number that's not going to be simplified, plus 3 root 3k, and then I get 5 root 3k. So again, just adding those coefficients together. Okay, that is good for today. The rest of these are just more of the same, but I want you to focus on the ones we just have done. All right, I'll see you back in Zoom.